So we're going to come back to this definite integral we were looking at here. So same graph as before. So we have the graph of f of x equals x squared. And where we kind of left off is we're going to approximate this integral with the Riemann sum from 1 to n of f of x sub I times delta x. Now we want to kind of figure out some things about our delta x and our x sub I. So first off, we mentioned this before, the delta x is going to be the length of our interval. So from our starting point to our ending point, right? So in this case, a and b. So it's going to be the length of our interval, b minus a, and then we're going to divide that by the number of rectangles, n. That's what our n is keeping track of up here, number of rectangles, and that's what this n is keeping track of too. And then our x sub I. So we want to be kind of specific about which x's we're using. And we're going to keep talking about the right-hand rule, what we were using before. So last time we looked at like the right-hand side of our rectangles. So we wanted to make sure that we were grabbing that right-hand side. So how we're going to keep track of that, we're going to say, okay, let's go to our starting point, and we're going to add to that our delta x. So however far over we need to go, however many times we need to do it, right? So for that first rectangle, we're going to go over delta x one time from the starting point. For our second rectangle, right, we're going to go over 2 delta x's. Our third rectangle, we're going to go over 1, 2, 3 delta x's, and we'll just keep doing that until we get to n. Okay. And then these are kind of the pieces that we need to find our Riemann sum for any number of rectangles. So let's go ahead and do this Riemann sum for a general number of rectangles, for n rectangles. So that's going to be, let's see, the integral from 1 to 3 is what we were looking at here. The integral from 1 to 3 of x squared dx. And we're going to approximate that with the Riemann sum the sum from 1 to n of f of x sub I times delta x. Okay, well, what's delta x? Delta x is b minus a divided by n. Well, b minus a is 3 minus 1 over the number of rectangles, and we said we're going to do n. So that's 2 over n. Okay, that's fine. And then what's x sub I? So x sub I is our starting value, which is 1, plus delta x, which is 2 over n times I. Okay, and then what's f of x? Well, this is f of x squared. So we're going to plug in the pieces that we know. So we're going to plug in this x sub I. We're going to plug in this right here into our x. So that's going to be 1 plus 2 over n I squared times 2 over n. Okay, now we need to do some algebra. We need to simplify this out. This here is a perfect square. And if you recall, perfect square is a plus b equals a squared plus b, 2ab plus b squared. That's a 2ab plus b squared. So don't forget that middle term that I almost messed up. So here our A is 1, and our B is this lovely 2 over n times I. So let's see, what do we get here? We get the sum from 1 to n of 1 squared, which is 1, plus 2 times 1 times 2 over n I. So that's 4 over n I plus b squared. So I've got to square everything here. So 2 times 2 is 4. N times n is n squared. I times I is I squared. And I'm still multiplying by 2 over n. Okay. And now I'm going to distribute my 2 over n. So I get 1 times 2 over n is 2 over n. 2 over n times 4 over n I is 8 over n squared I plus this whole thing times, so I got 8 over n cubed I squared. Okay, and now we're going to use a bunch of our properties. So I'm going to use my first property that says I can split up the inner sum. And I might as well also pull out the, well, let's do it all in steps here. So we're going to say this is that sum plus this sum plus that sum. Okay. Now let's remember here, n is the number of rectangles. That's a constant. So that means this is a constant, this is a constant, and this is a constant. So for this one, we kind of have to leave it there because we don't have anything else. We don't have anything else to leave behind if we pull it out. But we can factor out this constant and we can factor out this constant. So this one we get that sum. So we have this n times, right? And then this one is 8 over n squared times the sum from 1 to n I plus 8 over n cubed times the sum from 1 to n of I squared. Okay, now some more summation properties. This one is just 2 over n times n. Okay, this one is n plus n times n plus 1 over 2. Okay, and then this last one is n times n plus 1 times 2n plus 1 all over 6. Okay, now we've got some more simplification to do. We're going to go ahead and factor these out. So let's see. This n's cancel. I just get a 2. So that's nice. Here I get 8 over n squared times n squared plus n. There's a couple ways we could have handled this, but let's go this way. Plus 8 over n cubed. Okay, let's see. This is going to be n times 2n squared plus 3n plus 1. So I'm going to factor in an n here. We get n 2n cubed plus 3n squared plus n all over 6. And then I'm going to multiply these fractions and divide them. Or I'm sorry, multiply these fractions and separate them. So we get 2 plus, I'm going to distribute and then multiply the denominators. So we get 8n squared over 2n squared plus 8n over 2n squared. Okay, and then plus, okay, I'm going to distribute that 8 and then multiply those together and split up. I've got 3 different fractions here. So 16 n cubed over 6n cubed plus 24 n squared over 6n cubed plus 8n over 6n cubed. Okay, and now we've got some cancellation. So we have a 2 plus 8 divided by 2 is 4, and my n's all cancel, so 4. 8 divided by 2 is still 4, and then one of my n's cancels, so I get 4 over n. 6 does not go into 16, but this does turn into 8 over 3, so plus 8 over 3, and my n's cancel, plus, let's see, 4, and I get an n on the bottom, plus, okay, one n cancels, and this is 4/3, 4 over 3 n squared. Okay, almost there. So we get 2 plus 4 plus 8/3. Okay, so 2 plus 4 is 6, which is 18/3 plus 8/3. We'll save that for the next step. And then I've got 4 over n plus 4 over n. So that's 8 over n. And then only 4 over 3n squared. Okay, almost done. Whew. 18/3 plus 8/3 is 26/3 plus 8 over n plus 4 over 3n squared. Okay, so what this means is we can approximate our integral from 1 to 3 of x squared dx using that little formula. So give me a number of rectangles and I can plug in those ends and we can get a pretty good approximation for that integral. We will get it even better in the next video.